Here's a quick video to help you with one of the perhaps more difficult homework problems on your Savvas homework. It's probably question number 4, but things could have changed in the software program, so hopefully this question looks familiar. I have this gnarly looking equation and I'm asked to solve for t. The equation that you see on your software program on Savvas is going to look just like this, but it's going to be probably different letters and different numbers. I'm going to show you 2 different ways to solve this. You choose the one that works easiest for you. In the method that you see here, the first thing I did is I said m is attached to this parentheses by multiplication, so I divided both sides by m. By doing so, I now had this equation, and remember, solving for t means I need to get t by itself. So now I move the 5 to the other side by subtraction, because remember that's really a plus. And at this stage, I still don't have t by itself. T is connected to the x is attached by multiplication, so I divide on that side, and I divide on that side. Those x's cancel, and now I have this big, ugly equation for t, and that is solved for t. But let's say you don't like that. Let's say you say, you know what, that looks like a mess. There's got to be another way to solve this. I invite you to try this. I'm going to give you the first step. It's the same equation, but now instead of the solution up above, my first step is I'm going to distribute the m into both of those. Go ahead and pause the video and go ahead and then try to solve for t, get t by itself, with that distribution being your first step. Hopefully you paused this and tried to work it out. After the distribution, that's what your first step would look like. Remember, you're trying to get the t by itself, so now I want to get rid of the 5m, move it to the other side. You're still trying to get the t by itself. The mx is attached by multiplication, so I would divide, and I have my answer. This is solved for t. In the first method, I also solved for t. Although those look like different answers, they're algebraically equivalent. But I suggest this method over here probably works easier.